this month's feature of the month is on cohort analysis. So if you attended Learnosity's Aggregate conference in New York earlier this year, you may have seen a talk given by Michael Sharman, Director of Product and Engineering, and Dennis Hochter, Director of Product and Business Intelligence. In that talk, they gave an introduction to aggregate reports. Those titles, engineering and business intelligence, make Michael and Dennis the right people to introduce aggregate reports, because this new reporting type sits right at that intersection between engineering and business intelligence. It provides some new tools to extract powerful insights into your data. So that initiative has matured since that Aggregate conference back in May. And so today I plan to give you a more detailed look at that new functionality. So the rough agenda, we will, let's see. So we're going to describe how we got here. I'll give you an overview of the functionality. We'll look at the use cases and the limitations of the system before digging in and having a look at how it's all put together. And I'll show you some code samples, and won't spend too much time on that, but show you there are 4 or 5 steps that go together to make this happen. So a quick look at the old and the new. If you haven't seen aggregate reports before, here's a sneak preview. On the top, you see the results of one student taking one assessment. Anyone that has used Learnosity for a while now will be familiar with that session summary report. Aggregate reports shown in the second image provides a meaningful, at a glance overview of as many as 200,000 students. So, very different situation. I'm going to briefly look back at the foundations of the Learnosity analytics and talk about what got us this far. So as you'll be familiar, we have 2 analytics APIs. Those are the Data API, which is server to server. There is no front end on that. It provides read-write access to your data. And I think of all the APIs, it's probably the most open one that we provide, given that you can, at any point, depending on your use case, you can access your data, you pull it back, you do with it what you need. You can update the data on our side, so it's very flexible. The Reports API, with the Reports API, we try to anticipate the types of reports that most of our clients will need. So the one you saw earlier, the session summary, is an example of that. We try to provide those out of the box, so you don't have to go and do all that coding yourself. As always, Learnosity is very interested in the idea of reducing the heavy lifting that our clients need to do. So if we can identify common tasks that you guys are doing on your side, we try to do that for you. And the reports, we also have a no UI mode. So if you don't like the graphical elements or the UI that we provide, you can switch that off and just take the raw data. So all of this is achieved by recording your data in the form of sessions, a session being one student taking one activity or assessment, those students' responses, scores, be they auto-scored or manually scored, and any associated metadata. So all of that goes into a data warehouse, and from there we extract the 20 or so common report types. And as well as that, of course, we provide those data API endpoints. So that's the old stuff. Now, the new infrastructure. In Sydney, we have a team of developers with the mission statement to make our customers' data easily accessible and more valuable. So in 2016, they built out the infrastructure to facilitate large-scale data analysis. This introduced an analysis engine which looks at the data which we already have and try to make it more meaningful. So you can see in the second image here, this new analysis engine, it slots in between the data warehouse and those existing report APIs, data and the reports API itself. So the 2 of those are still used in the implementation of aggregate reporting. Cohort analysis is another, I think that expression is almost interchangeable with aggregate reports. So it's worth talking about that just for a moment. Cohort analysis takes the data from a given data set, and rather than looking at all users as one unit, it breaks them into related groups or cohorts for analysis. So those related groups will share common characteristics within a defined time span. Cohort analysis allows us to see trends clearly across the performance of students, and it allows us to compare one group to another. So that comparison of one group to another is an important part of this. The data superset should be divided into cohorts in an intelligent fashion that suits your use case and your needs. So we're not going to be pushing any particular. There is an example that we use a lot, which is state, district, school, class, and that one I'll use in my presentation this afternoon. But it's really up to you how you define those cohorts. And aggregate reporting. So the goal of any business analytic tool is to analyze and present actionable information, and that's what we try to do with this new reporting functionality. A database full of hundreds of thousands of entries, that data, it can be difficult to extract actionable data from it. So we hope to help out in that regard. So yeah, so these are the key points. This slide kind of defines the whole thing. So meaningful analysis of your data. So as we described before, get more value out of that data. Customizable graphic report shows the key data at a glance. We had a sneak peek at that in one of the earlier slides, and we'll be seeing it in action in the next half an hour or so. Compare and explore cohorts of up to 200,000 students. 200,000, that number was picked purely because we couldn't find a district which had more than 200,000. So we just decided that was the number we were going to pin to this thing. If you do have a use case that requires more than 200,000, you can just speak to us and we'll see what we can do. Show mean, median, percentile, standard deviation, and many more. There are, in fact, 214 different options. These are the statistical measures that we find that are delivered via the aggregate reporting. 200 of those, though, are percentiles, those being percentile scores and percentile percentages. You'll see that in action a little later. This is a point-in-time snapshot based on activities or sessions. It's up to you when you generate these reports. I think you'll find it makes sense perhaps monthly or quarterly. You create them whenever you need them, and they're typically available within 1 hour, because this is it's a cron job. So you tell us you want it, we go and generate it for you and send it back. However, I think with smaller data sets, you'll find that they're typically available much faster than that. Pre-computed, so we run the numbers for you. This kind of reporting can be resource intensive. Not everyone has the time and the resources to plan, build, and maintain an analysis engine. So we felt this is something that would benefit a lot of our clients, which is why we made this available. You define the cohorts, endless flexibility. So that's a very important part of this. It's all about the cohorts and finding a hierarchical grouping of your users that makes sense to you. That will probably make more sense when we see a few examples of it, as we will this afternoon. The hierarchical structure, drill down into your data, you'll see how you can click level by level. You can go into more detail, and so there's a nice a UI report which you can click into, and there's a back button. You'll see that in action. Includes optionally student level scores. So the lowest level in any hierarchy, given that this is all based on students, is those students' individual scores. And there are 5 parameters that we present those on, and those are we give you all 5, and it's up to you how you use them. But it's generally the student's score, and we have other things like the max attempted score, unscored max, and seeing activities and so on. We give that to you in the data that comes out of these reports in case you have a need for that. So the use cases, who uses this, and who should you as a client, who should you make it available for? So probably 2 ways of looking at this: the administration level, which is policymakers, district administrators, and so on. That's at the larger view when you're looking at states, districts, schools, or at a local level, principals or teachers looking to understand class performance, compare class with class, teacher with teacher, or any sensible user-defined cohort. Here we I think skip the slide here. So here we have a couple of examples of the groups and hierarchies. The one on the left column is probably the easiest to understand, easiest to visualize: state, district, school, class. But you can see in the other two boxes here just some ideas. We are in no way opinionated about what those cohorts should be. We won't define any of them for you. That's entirely up to you. So an example cohort hierarchy. Important to note that you will need to have the data on your side to support dividing your students into cohorts. So in the example here, it's this group path defines the hierarchy and the levels within that hierarchy. So this is district, looking at the first one here, this is district, school, and class. You can see that the district is called the Simpson district. Within the Simpson district, we have Springfield High School. Within Springfield High School is class 7, Mrs. Crabapple's class. So that's one example of how you would define a hierarchy. And then you tell us all of the students that are in that hierarchy. And that's presented as ND-JSON. That's a new line differentiated JSON file. We'll see one of those shortly. Second one, it's kind of the same data, but we're looking at it a little bit differently. In this one, I've removed the district level. So we start with the school, then we go to the class, and within that class is attendance. So taking one of the options from that the middle box that you see above, attendance, for this one, you would need to have records of your students' attendance. Then so this 90% one that you see, all students who have 90% attendance or more, they're in one cohort. Then you might have an 80% attendance, 70%, and so on. All right. So let's have a look, just a graphical view of how these things are. Here again, we have the district, Northern District, District B and District C. Within those districts, we have schools. Inside of the schools, we have classes. And again, this is about comparing. So you will, in a table format, that's the kind of the default mode is a table layout. You'll be able to see numbers that compare class B to class C, Mrs. Hoover's class, etc. And you can, if we're tired of looking at the Northern District, you can navigate back out and go back into District B and District C and so on. The comparison, again, it's all about that. And those statistical measures that we provide, you see some of them examples given here, the mean, the median, the min, max, percentiles, and so on. Separation of data. So as you may know, Learnosity, we use the principle of least data, no personally identifiable information. So in the central column here, you have a student called Gavin Cooney from Arizona. Gavin has a student ID and a unique reference. It's that unique reference which is of interest to us because that's the user ID used with Learnosity. You see unique reference 1, 2, 3, 4, 5, 6, 7, 8 is also used in the Learnosity records on the right-hand side. And that's really all we care about. We don't want the student's first name, surname, what high school they went to, any of that. We don't deal with that. We don't record that information. But you need that information in the reports. So that's linked by the host system. The host system is you, the client. We provide a lookup method that maps those IDs to your display-friendly labels. So you might have unique reference 1, 2, 3, 4, 5, 6, 7, 8, and then you'll have a mapping table which maps that to the student's name. All right, so here we have a kind of schematic view of how all of this works. At this point, I'm going to break away from this presentation and let's dig in and have a look at how all of this goes together. Rather than explain it from this graphic, we'll have a look at, first of all, this link to the documentation is at the end of this presentation. So it's definitely the place to start when you want to learn more about aggregate reports. So we have an implementation guide, and within that implementation guide, there are 4 steps highlighted here, and I've got a demo that shows how these work. In fact, this demo is arranged slightly differently. We've got five steps here. The first one is to initialize a dataset aggregation job. So this is you telling us what you want our service to do for you, what kind of a dataset you want us to generate. So there are 2 types: activity summary by group and session summary by group. The activity is, as you can guess from the name, it's based on an activity, all students that take a particular activity. We could also do it with sessions, but for today's demonstration, we'll be using activity. The file count, that is the number of files that come out of this. It's in smaller data sets, we'll be using 1. The filters, so here we have the activity ID. So this report will all be based on students who took this particular activity. Then we move on to some configuration options. The mean percent, and so this is how when each table view at each level of the report, we need some filtering on that, and we allow you to define that. So in this case, we're using the average percent, and it's arranged in a descending fashion. The fields, these are the statistical measures that we provide for you. Let's have a quick look at those here in the docs again. So things like the population, that's the number of students, low score, high score, the mean number of seen activities, the mean score, median. These are some of the percentiles, standard deviation, lowest percent, highest percent. So it's just about everything we could think of in terms of statistical measures. That's all made available to you. So that's all in here. In this case, we're going to generate a report that returns all of them. The user fields, so this is the last level, or the leaf level in a report. So this is as deep as you can go into a hierarchy. And the last level is, of course, the student scores. So the user fields, are 5 of them, as listed here. In this example, we'll be asking, the report will contain all 5. The groups, this is important. So this defines the structure of the hierarchy. So in this example, we're going to use district. Inside of those districts, we have schools and then classes. So I'm going to hit this button, which calls a endpoint on the data API, which is here, and that will initialize that dataset creation job. Moving on to step 2, which is here, upload the input files. I think it's easier to explain that over here. So here we have an example of a ND.json new line delimited JSON file, which has a good number of students, and those are broken down into the hierarchy that we described above. So looking at the first one, Simpson is the name of the district, Springfield High School, and 7 Crabapple is the school. So these first 10 or so students are all in that class. Then you've got Hoover's class and so on. So we're going to upload that data. That endpoint gives us a 200 OK, so we're good to move on to the next step, which is commence the dataset generation job using the data API. And that's just a simple, a different endpoint. But yeah, so that is now in action. The Learnosity servers are now working away on that. Over here we have this poll button. So this is the thing that with very large data sets, those 200,000 records we spoke about, or 200,000 students, it can take up to an hour. In this case, given that it's only like 50 students or so, it's quite quick. So we can see this one is already completed. And so that brings us down to step 3. Now we're on to step 4. Retrieve the results via the data API or reports API if applicable. And we will be using the reports API here. So I'm going to generate the standard report, and here we have it. So here are the two districts, Simpson and Walter. That data is coming from here. As I scroll down through this, you'll see Simpson. These are all of the schools within the Simpson district. Then towards the end, we've got the Walter school. So that's the hierarchy, and we can click through. Here we see the three schools. This particular one is a little bit crowded looking, given that all of the statistical measures are presented here. So I've got a second option. You can see these buttons here. This is just a JavaScript method, so you can write these on your side. You can do this. Allows you to change change the columns that are presented, and that makes the whole thing a lot more flexible. And that is the most standard version, where all we're doing here is we're presenting numbers. We've got a different type. So each time I hit this button, we're using exactly the same data set, just presenting the data in a different way. So here we have a box and whisker graphical element describing at a glance the outcome of this report. Now, if I flick between the second and the third one here, so in the Simpson district, the lowest score is 10, the highest is 100. That can be seen here by this whisker. Is at the 10 mark, and the maximum is 100. Inside of that, we have medians are defined. So we see that the median of the entire data set is 55. We also see 40 and 78. So 40 would be the 25th percentile, and 78 is the higher percentile. Looking at that in the table format, you see it here. Actually, in this one, we don't have the 25th percentile. So very quickly, I'm just going to add that in. So here is the method that tells the, well, it's just about how the report is rendered. So here we have the 75th percentile. Very quickly, I'm going to add in the 25th. So if I save that, I now need to refresh this page. Very quickly, we'll go through this again to show you how updating that JavaScript method will change the output of the report itself. You can see over here the poll job is now telling us that this job is still running on the Learnosity server. So we poll it again. Now we see that it's completed. Now we can generate the reports. And it was this one that I updated. So now you should see the 25th percentile is in here. And we see that for the Simpson district, the 25th percentile is at 40, and that corresponds to this view where you see 40 as so it's the lowest. The number 40 in this case, it defines the four quarters, the four quartiles, Q1, Q2, Q3, Q4. All right, so I'm going to dig down a little bit more into this. Inside of the Simpson district, you have 3 schools. Let's look at the Hogwarts school. And as we go through it, you see that at a glance, it shows you what's going on here. So the blue box is the Q2 and Q3. And the idea is that as you compare these 4 schools, you can see that the second school, Gryffindor, seems to have the highest median value, which is 68. And the median is, that's a good indication of overall performance. You also see the range. So the range in all cases, in fact, the lowest score was 10%, and we've got a maximum of what looks like 90% in the second school. And that's a graphical element over here. This is a 1D plot, one-dimensional plot, and it's just a way that you can lay this out. So in this case, we're using max, min, and those various percentiles, and those are all user-defined. So just looking back at the code very quickly. Sorry, that's a numeric version. Down here we see a scale bracket, a whisker plot is defined, a box plot, and these aren't standard. These are defined here in the code. So you tell us that in that box plot, you want the minimum value to be the 25th percentile, the maximum value to be the 75th percentile, and the middle to be the median percentile. That's what you see here. And we find that this is a very, it's a good graphical at a glance representation of what's going on in that particular school. So we can click down one more level. This is Ravenclaw. And in here, you're at the individual students level. So here you see just their actual scores. Another thing I would like to do as just a quick example is I have a different input here, a different cohort defined. So you can see how that affects things. So rather than that default one, which is district, school, and class, we're going to change those cohorts and just show you how that looks. So in this particular case, what we're doing is we're removing the first. Okay, we're removing the first level of the hierarchy, which is district, and we're just getting rid of it completely. So level 1 now will be a list of schools, and we need to update this. So previously, level 1 was district. That's now gone. And we're adding a new one onto the end. So this will be attendance. So the attendance data, let's have a quick look at that. So you see, let's pick George Weasley here. So he goes to Hogwarts School, he's in Gryffindor class, and he is in the cohort that represents 80% attendance. So he has attended 80% of classes. That data, Learnosity doesn't know that, we don't store that, you tell us, and then we use that to generate the reports. Oh, sorry, before I do that, of course, I need to initiate the Dataset Generation job. That is now done. I'm uploading my user data, commenced the Dataset Generation, and now we're back to the polling again. I think I find that this takes about 15 or 16 seconds. Running, still running. Okay, there we go. So that's completed. Now, looking at those reports, I'm going to skip that first one again because it's just too crowded. So here we have the first level, as you'll notice, is the schools. The districts has been removed. If we click into Hogwarts School, Ravenclaw, here you now have a new cohort, which is attendance. Attendance in 3 different groups. So this tells us that those students who had a 90% attendance had a median score of 60%, and those who had lower attendances had lower scores. So it's just another way of slicing across that data. Okay. Oh yeah, there is one more example of this I want to show you, which is this one. Over here we've got this is the 1D plot, but you can see the difference between these two. You can add in extra elements. So in this one, we're marking the 90% over here. You've got this gray shaded area, and what that represents, I'll give you a quick look in the code. So it's defined here, the shading plot. So the source of this data is the parent, so the level above, and we're showing the 25th percentile and the 75th percentile. So if we click back to Hogwarts School, in Hogwarts School, you can see that the medians are defined here. It looks like 40 up to 75. If I click through on Hogwarts now, you see that the gray area is still visible. So there may be cases where it's that represents a better way to display the data. So that is pretty much it in terms of how it all goes together. Let me see. So we've got a couple of more things to go through here just to round up. So to summarize, it's completely customizable, as you've seen. I think the most important thing here is that the cohorts themselves are customizable. We don't get involved in any way there. We leave this wide open, so you tell us what you need. We generate that data for you. We provide all of those, the maximum of 214 different statistical measures. We give you all that back. It's processed asynchronously. It preserves your privacy and security, and it's extensible in powerful ways. So here's an example of how it might be used. So at the end of each semester, you may generate a report using this tool. Even though aggregate reports are new from Learnosity, it's worth mentioning that because it's all based off sessions and activities, you can generate these reports retrospectively. So looking back at semesters 1 to 4 of 2016 or before, if you've been using Learnosity back in 2015, it is now possible to generate these kinds of reports looking back at all of the data that you've been storing with us, which is particularly valuable if you've got a couple of years of data there. So you can analyze that data in a lot of useful ways. The limitations. So as there is a lot of number crunching going on here, we do have some limitations. I mentioned the 200,000 users before. Even that is, it's not a hard limit. We can do something with that if you can present a use case where you feel this should be increased. There's a maximum of 5 group keys in the hierarchy. So in the examples we saw, there were three levels. So we could have had state, district, school, class, and perhaps attendance. That's the most that we can do. It's 5 levels of a hierarchy, which I think meets most use cases. We have a maximum of 1,000 immediate children for any parent group. There are 2 types of these reports, or two ways of narrowing down the data: activities and sessions. When you're dealing with activities, there is a limit of 10 activity IDs, and with sessions there are 50 session IDs. The other 2 points there are just about the size of the keys used. It's implemented using datasets asynchronously. Once completed, the data set can be retrieved, and so we have a point here in our docs about designing report data. That one I've added into the notes here because I think it's worth pointing out. Should you use activities or sessions? How should users be grouped? Now, we give some examples here, but really it's up to you how that's done, and you need to think about what makes sense to you, what kind of reports that you're going to need. And I think we're coming to the end now. Let me see. Yeah.
I think we have a few questions as well, David.
Mm-hmm.
I'm not sure whether we'll be able to answer them all on the webinar or not, but we have a question in from Jackie Laviere asking if the hierarchy is fixed containment, or can she, for example, have a group of students with 90% attendance that crosses all schools, or does that need to be defined at the lowest level?
It needs to be defined at the lowest level. So let me go back to my example data set here. So looking at the first level, we have the 70, those students who are within Mrs. Crabapple's class who have a 70% attendance. So this is hierarchical. So the first level must contain all of the schools in the second level. So it's step by step. You can't have 70% attendance for every Springfield High class. So I hope that answers Jackie's question.
So we have a follow-up question from, it's actually Kent, not Jackie, and asking about the 50 sessions and 10 activities and how that might work for hundreds of thousands of students.
Okay, limits. Let me see. So the 50 sessions are, yeah, okay. That's the 50 sessions does seem quite low in that regard. Actually, the activity ID, I think if you're doing, tens of thousands of students, then it's quite easy to. I think the more useful version of the report is the activity summary by group. So all of those 50,000 students may have taken the same activity ID. So you provide that activity ID as the very first parameter right here when you are initializing the dataset aggregation job. We then know that all of the student scores are based on their scores for that activity ID. Here we have one example, just one provided in the filters. We can deal with up to 10, but I think that's if you're dealing with 50,000 students, that would be the way to do it.
Okay, and there's another question in from Nicholas Anzalone asking if it is a requirement that the groups are disjoint.
That sounds, if I understand correctly, it's the different way of asking the same question.
Okay.
So here we see the 70% people and the 80%, they're all subsets of this level, the mid-level, the class level in this case, and that in turn is a subset of this one. But that is the way that you need to construct your user file in that way. So this last level is a subset of the level before it, and likewise that is true all the way back to the first level.
Excellent, and this is possibly related again, but from Lane Rushing, he is asking if you can specify multiple activity IDs if they are related. You
can, yeah. So that is done here. In the first step, you can provide up to 10 activity IDs. And then all of these statistical measures will take into account all 10, well, if you use the maximum amount. So we would have the lowest score per student. So in that case, the lowest score would be this particular student's lowest score across all 10 activities. And the same is true of all of these. So the average score would be across all 10 activities.
Okay, excellent. And the final question in, and I think this is probably more of a roadmap question, and that's just asking about plans to increase the limits for activities and sessions. So that may be something we might need to come back to you on. Yeah,
I think in the meantime, given that I know for at least some of these limits are arbitrary, if you have a particular use case where you need to increase any one of those limits, I would suggest that you get in touch with your support representative and present your case, and we'll see what we can do to get that increased for you.
Excellent. Well, that wraps up all the questions that I see here. So I guess thank you, David, for a really informative webinar. And thank you, everybody, for joining and giving us your attention. We'll have the recording up shortly.
Okay. Thank you, Rachel.